Hello, great number divided by number. They're not scary at all. They're just, we have infinite number of numbers, and these numbers count just as much as our integer numbers. So go ahead and check that out. What's the difference between a rational and irrational number? Um, and this is really cool. This is a really cool link right here. This is showing what they all mean. Okay, so I'm going to take out these and start. All right, so we have natural numbers. Our natural numbers, you have already went and found all the definitions because that was the first thing. Hopefully put me on pause and found the definitions. But anyways, the definition of a natural number is just a number, a counting number from 1 to infinity. It has no negatives, there's no fractions at all. Right? Whole numbers are embedded, like natural numbers are embedded within whole numbers. We can see that right here. 1, 2, 3, 4, 5 is right here too. 1, 2, 3, 4, 5 is there too. So, but whole numbers include one additional number, and it's the number 0. So the natural numbers or whole numbers are very, very similar, but whole numbers have 0 as well. All right, and then integers. Well, we're going to have natural numbers and then whole numbers and integers. These guys, these natural and whole numbers are inside of integers as well. Like here we can see like 1, 2, 3. Oh yeah, it's right there. Oh, 0, 1, 2, 3. Oh yeah, it's right there. And then, but integers also have fancier numbers. They have all negative numbers as well. So those are our integers. We have no fractions here happening. Integers are just negative numbers from negative counting numbers. So that go from negative infinity to positive infinity. And you guys know what the infinity sign looks like, right? The infinity sign, I'll make it like with my finger. It's like a sideways 8, right? That's the infinity sign. Right, and then next we have our rational numbers. Our rational numbers are inside of all of these. And they can be written as an integer divided by an integer. That's it. It's just a number over a number. It's a fraction. And then lastly, we have irrational numbers. Irrational numbers cannot be written as an integer divided by integer, such as pi, right? Pi 3.14159, blah, 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 it keeps on going on. It's not just a nice number divided by a nice number. So those are irrational numbers. All right, so if you haven't already done so, please make sure you get all those definitions down on this sheet, and you have also put all of your examples as well. Real numbers, all of these numbers, all of the natural, whole, integer, rational, and irrational exist within real numbers. Right, so there's actually only one, it's not really a number, that doesn't exist in, and we're going to talk about that more on Monday, but that would be a number that's divided by 0. Those ones do not exist. All right, so I'm not expecting you to copy this out or anything. You will be getting this sheet on Monday. But let's just talk about some of the short forms, because you can add some of these details to your definitions. And guess what? If you didn't write the definitions, here they all are right here too. So when we're looking at natural numbers, the short form is, hopefully you guessed it, an N. And then we just talked about the mathematical description. It is 1, 2, 3, and then keeps on going to, let me write that in sign for you, infinity. Integers go from, which we can name as I. Sometimes people name it as the letter Z, but are the positive and negative whole numbers, including 0. We also have whole numbers that we talked about already. That's 0, 1, 2, 3, going up to infinity. So it includes all the naturals, but also has a 0. And 0 kind of looks like a heart. All right. And then we have irrational numbers. Irrationals are non-terminating, so that means it never ends. So such as something like pi or the square root of 2, those are all non-repeating and non-terminating. So they never, the decimal just goes on forever, is what that means. They're like really ugly looking numbers. Rational numbers are fractions, so like 1 over 2, or how else can you write 1 over 2, but maybe as a decimal? Yeah, I bet you know what it is. 0.5, things like that. Where they're ending. See how it's 0.5 done, nothing else? That means terminating. It doesn't repeat. But we can also have repeating ones as well, like 1 over 3. Maybe you know what this one is. This one's equal to 0.333, repeating on forever. You know what sign you'd put on top of this last 3? Hopefully you know that. You put a line on there. And that means the 3 repeats forever. Those are all rational numbers. They're pretty nice numbers. They're not funky looking like the rational numbers that could just, they're just so random, right? It's like pi 3.14159. It keeps on going on for the rest of eternity. All right, and then we have real numbers. All of these guys are included in the real numbers. Rational numbers, irrational, whole, integers, natural. Those are all, that's why it says Q, which is rational. Q means rational. And irrational would be like Q with a bar on top. That means irrational. So those are the symbols. So this letter, or this big U sign right here, just means and. So these and these are all included, all rational and irrational numbers. So all rational. Rational is Q. They couldn't use R. You know why? Because R is real. So they couldn't use R, so they picked Q and Q bar for rational and irrational. And the symbol here we have is real. For not real, it doesn't have a symbol, so there's no symbol, but something that is not real is like 5 divided by 0. Any number divided by 0 is undefined, so we call that undefined. It doesn't exist. You can't take nothing from something. All right. I'll give you some time to just like pause and look at this for a second. So here we have, what are some similarities between natural versus whole numbers? Maybe you found some similarities. Maybe there's some differences, right? When you're looking back at natural numbers, natural are for 1 through infinity. And we have whole or, oh yeah, that also has 1 through infinity. But it does have a 0. So there's some of your differences. So your difference would be this one has 0, and this one, they both have 1, 2, 3, to infinity. So, and maybe you can say like whole numbers have 0. All right, so just check some of those out. Again, W means whole, Z or I, that means integers. Sometimes people like Z or I. And then again, I or integers are rational numbers and rationals and irrational. I don't know why I have the P here, but it should be Q bar. Again, some people use different symbols, but those are the ones we're going to be using. All right, so check out some of their similarities and differences. And then lastly, for today, if you've done all that, you are going to be check marking. So complete the table. Again, I'm going to be posting this. You can just create your own chart on a lined piece of paper if you don't have a printer. I'm never going to ask you to go get a printer. And then you can work on this page too. So for the first one, we have the 7. Does 7 exist in natural numbers? 1, 2, 3, 4, 5, 6, 7. 7 is there. Whole numbers, it's also there. Integers, yep, 7 still exists there. And 7 can be written as 7 divided by 1. So 7 divided by 1 is a rational number. It is not an irrational number, because it is, you can either be one or the other. You can't be both. Okay, you can either be rational or irrational. You can't be both. You're just one or the other. And then we have real. All these numbers are real. There might be one that's not real. Yeah, I do see one that's not real, but everyone else should be real. Okay, so I just gave that away. There's one of them here that is not real. Everybody else gets this check mark of R. All right, so when you're going through it, if you see something like this, like a square root of 3, go and calculate the square root of 3. All right, so I'm right here now. I am finding my Desmos calculator. This is one of the best scientific calculators. I just typed in Desmos scientific calculator. I'm going to go use the square root button. Square root of 3. All right, wow, look at that, 1.732050808. It probably definitely continues. All right, so let's go check and see where that exists. So again, if you're not sure, you're always more than welcome to use this chart. Is that number right here? Do I see it? No, it's not a natural. It's not a counting number. 1.732. Yeah, no, it's not there. An integer? Nope. Is it a whole like counting number? Nope. Is it irrational? Is it like weird and different and like not very common? Absolutely. This one's definitely irrational. So let's go scroll down here. So it's not whole, it's not a natural, not an integer, it's not a fraction, it's a irrational, and it will be real as well. So all these, even if you're irrational, you still exist in the real world of numbers, because it's a real number. All right, I'm gonna do a couple more with you guys, and then I'll leave the rest of it for you to do. All right, we have 3 over 4. 3 over 4 is also the same as 0.75. So if you don't want to work with a fraction, that's all right. Just go on your calculator. You know what's really handy? You just hit enter and you get a new line. And you can put 3 divided by 4. So that little division sign happens here when I hit divided by, and I get 0.75. You can also click this button and it changes it back to a fraction. Oh, that's magic. All right, so is it a natural? Yell it out, yes or no? No. Is it a whole? Definitely not. Is it an integer? No, it's not a counting number that's negative or positive. Is it a fraction or a decimal? Yes, that's ending, it's terminating, and it's not, our definition here, it's all fractions repeating and terminating. So it's not repeating, but it is terminating. So yes, it's going to be there. Can you be both? Can you be both rational and irrational? Just like in life, can you be rational and also irrational at the same time? No, you're either one or the other. So nope, this one's being rational and it's real. All right. If you do have any other questions, please just send me a message. The quickest way to message me is over Teams. I've added everyone to our team. Uh, so if you've used Team before, that's awesome. Just message me over Teams, Jennifer Johnston, and I can get back to you. That's the quickest way. Or send me an email, and I will get back to you as soon as possible. All right. Have a great day.